This is group 12 of lesson 9 and the group meeting for lesson 9. And this is Sam Quirwan and Ben Wiggins. Okay, question 3. Which hypothesis involves equality? Which is the null. The p-value is a probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember, the p-value is a probability of obtaining a sample statistic at least as extreme as the one that's actually. When computing the p-value, which hypothesis do you assume to be true?
No.
It's always the null, isn't it?
Yeah.
Suppose the null is mean is 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test? That would be not equals. Because the greater and lesser is a one tail on each one. That's the alternative hypothesis for a left-tailed test. It's less than, right?
Yes.
I think it points to the left is how I remember.
Mm-hmm.
And the right is greater than. Okay. Significance. Which relationship would result in failing to reject a null hypothesis? I think if the p-value, what? Say that again.
Hang on. What was your answer?
I was gonna say I think the p-value being less means it fails. So in failing to reject, we would want greater than.
I think so. Hang on. Hold on. It's
kind of a double negative.
It kind of is.
So I think it's the top answer.
The top one. So it's greater than the alpha, or less than the alpha.
Yeah, because if the p-value I think is less than the alpha, then you have to fail the null.
Yeah.
So failing to reject it would be greater than. Yeah. Okay, confusing. So then question 9 would be the opposite. An insurance company is reviewing its current policy rates. When originally setting the rates, they believe that the average claim was $1,500. They're concerned that the true mean is actually higher than this.
See? The average claim is greater.
Right. Which would be the null, which is equal to. The insurance company randomly selects 40 claims and calculates the sample mean of 1,650. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? It doesn't say if the population. So.
Isn't the N, isn't that the population?
No, the N is the number of people in the sample.
The claim, right?
Yeah. So the population is everybody, all the claims. The N, the 40 is just a sample. And you're supposed to have 75 or above for it to be large enough that it's always normal.
So in this one over here, not a good assumption.
That's my guess, because the sample size is small. What theorem or law justifies your answer to the previous question? This is what I was telling you I mixed up on the test. I don't know. I think the law of large numbers means the more numbers you are, the closer it is to the mean. So maybe it's the central limit theorem. Which of the following is as defined in this lesson?
Is it the X? Hang on. Got a cheat sheet here somewhere.
I have no idea. We've seen all the rest of these previously except for the S, but I don't know the lesson.
I don't recall running into an S in this lesson, but I could be mistaken.
Yeah. I think that one's a red herring. Right.
So what would your answer for that be?
I have no idea. The Z-score, maybe?
That makes sense.
Okay.
I'll go with that.
The historical mean of sale at a grocery store is $150, with standard deviation of 40. The store manager suspects that the average. She sets up a hypothesis test with the hypothesis, blah, blah. She uses a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes that. But it's 144. Maybe it is the X for the last question. Okay. Sorry, let me get back to it. What is the Z-score associated with this test? That's easy to figure out. Calculator. $144.50 divided by mean, which is 40.15. Negative 0.15, actually. Three decimal places, so we need to put a 0 on the end. What is the p-value associated with the Z-score? We need that applet thing, huh? Good thing I saved it on my desktop. Which one do we need? Which side? The less than?
Let's see. Shoot.
I plugged it into the app. Do you know which side of the app we're supposed to highlight?
I'm not sure. Hang on. I run into that. It's the left side.
Okay. So the p-value is then 0.4404. 0.4440.
What was the z-score in this one?
Or negative 0.015. No, I lied. I'm sorry. Negative 0.150.
0.150. Inference.
What?
Oh, number 17.
Sure.
What inference would you make about the null hypothesis for this problem? Oof.
Reject it or fail to reject it? I think it's failed to reject.
This one, yeah, because her alpha here is 0.05. This is rejected.
Yeah, because it's 0.440.
Yeah.
What is your conclusion for this problem? We have insufficient evidence that the true population mean is less than 150. Right. Yeah.
19. There are two types of error that can be made. Which type of, which one involves rejecting the null hypothesis when the null hypothesis is true?
I think that's a type 2.
Type 2, we agree, yeah. A researcher decided instead of using a level of significance of alpha equals 0.05, he uses alpha equals to 0.01. Which of the following will be true?
It's one of the top 2. The closer it is to failing to reject, or the smaller it is, the closer it means that you'll not reject it. So that would be type 1.
Type 1, I think so.
Nice. So are you working from the bottom? She's working from the top?
We have a message.
Oh, gotcha.
Okay, 21, I have no idea how to figure this out.
Me either. So it was going to be the answer was going to be at 0.05 as well too.
Okay.
Yeah, I just tried to fix it.
I think she still has her iPad, but you have to FaceTime her through her email instead of her phone number.
I'm gonna click submit and see how terrible we did.
Yeah.
We got question 12 wrong.
Yeah.
Z was right. Oh crap, we got that score wrong. How did we get that? Oh.
About 3 minutes.
Interesting.
On it right now.
We missed it. Oh, didn't we?
I was planning on sitting in on it, but
Oh, we got
So
question
we
21, right?
We can take this again, right?
Yeah, we can. We have 2 tries on this one.
Okay.
Yeah.
Through them again here. So question 12 is wrong.
the computer's just right outside the door.
And 15 and 20, 19, 20, 20, 19 and 20. 16, 19, 20. All right, I'm going to take this. I haven't had to take any of these twice except for this one.
Maggie, be nice. That's not helpful at all.
Okay. True. No. No. Two tail is not equals. Left less than, greater than.
Lots of stories.
Question 10. Is 100 equal to 200? All right. We're going to say it's a good assumption since it's the format, even though it doesn't say that.
Yeah.
Central limit theorem.
On rest.
Which of the following is a test statistic Z? All right. These, all right, so this is we need, oh, is it because of, it's because of this, the number. So she used 40 people, right? Oh, 36. No, the deviation.
You got it.
667.
Square it.
All right, so I'm going to say the Z-score is negative 0.8 which would actually become 0.90. So, question 6 associated with this. Negative 0.1841. 4. All right, let me get this. Now I got question 10 wrong somehow. They changed the question. Or no, I read that wrong. And let's see. But 15, question 15 is negative 0.9 and 16 4.
Again?
Have you submitted it yet?
No, I haven't yet.
Okay, so for question 10, average claim is greater than. I clicked the wrong one when I sped through it.
Average is greater than.
Yeah. Question 12, I also got wrong again. So we know it's not a good assumption since the sample size is small, and we know it is not. It is a good assumption because the population is normal. So it is either it is a good assumption because the sample size is large, or it is not a good assumption because the population is not normal.
My answer.
But it says central limit theorem. So my guess is it's a good assumption since the sample size is large, but it doesn't seem like a large sample size.
Yeah. And 16 was what was the 16 you said? 4?
So 15. What we did wrong, is we have to use the sample. We did 36 sales receipts. We need to take the square root of 36.
It's 6.
Then divide the null hypothesis. Sorry, divide the standard deviation of 40 by 6. 40 divided by 6 is 6.667. And then you take the difference between 144 and 150 and divide it by 6.667. And the answer for 15 is negative 0.9. And the answer for 16 is 0.184. So we fail to reject. We have insufficient evidence. Question 19 is type 1. Question 20 is type 2. And question 21 is, as you said, 0.05. All right, I got to get off. My wife has to run.
Okay.
6. So I will talk to you later.
All right. See you next week.
Bye.